And moving on to the next session, which is a panel discussion on Innovating on Wheels, the future of automotive engineering research and development. And the moderator for this discussion began his automotive career in 2000 and has expertise in electronic braking systems, body and security systems, steering systems, and autonomous mobility. He has a vast experience in setting up and leading research and development teams in global Tier 1 across multiple domains. He has a master's degree in automotive embedded systems and a bachelor's degree in mechanical engineering. Please put your hands together to welcome today's panel moderator, Mr. Jaidev Venkataraman, Head of Global Tech Center at Valeo. And the first panelist of this discussion is an accomplished professional with 30 years of experience in information technology, accountable for managing the technology teams and support functions of global Stellantis and IT and digital teams, and local support functions for their global digital hub. He has predominantly worked on automotive and financial services sector for the past 22 years, and prior to that worked on automobile industry with majors like GM through EDS, technical expertise in all aspects of the SDLC, as well as maintaining strong relations with the stakeholders throughout the product life cycle. And he has been spearheading the ICT division of Stellantis India as the Vice President and Head of India Digital Hub for over 18 months now, and has been appointed as the Director of the company effective December 2022. Please put your hands together to welcome Mr. Rahul Rajupalepu from Stellantis. And the next panelist is presently the Vice President Product Engineering, responsible for digital engineering, vehicle performance, test engineering, and technical affairs in Renault Nissan Technical Center, India. And prior to that, he served as Senior Management Delegate in Renault Joint Venture Company in China from 2019 to 2021, while he was responsible for product development and engineering quality for Renault China market and export markets in South Americas, Middle East and African countries, including the new EV development, carrying over 26 years of professional experience in the field of research and development. His key contribution includes successful Indianization of Renault Duster and several other products adapted from Europe to India, development of global small car platform, and growth of digital engineering center. Please put your hands together to welcome Mr. Balasubramanian N from R&T BCI. And the third speaker for this discussion is an accomplished global director with 30 plus years of track record in the automotive industry with Japanese as well as American OEMs, with international service experience of 8 years covering German, Brazil, China in the areas spanning manufacturing, operations, and manufacturing in engineering. Program management and product development with laser-sharp focus, on-time delivery with high quality, as well as lower cost and customer satisfaction. Operated with excellence mindset in all key areas and leveraging key skills like critical thinking, business acumen, providing oneness leadership and collaborative problem solving with passion for business and people. Currently leading the digital engineering transformation for manufacturing engineering globally, as well as implementing digital thread to cut development time by half. Let's welcome Mr. Kandasamy Subramanian, Director of Global Digital Manufacturing Engineering, Ford Motor Private Limited, as the third panelist. Over to you, sir.
Thank you for the introduction. Good day, everyone. So it gives me immense pleasure to talk about mobility with this eminent panel of mobility players assembled here. So my name is Jaidev. So I come from Valeo, automotive supplier. And in a role reversal as a supplier, I'm going to question all the OEMs. Okay, so I'm as excited as you to delve into this world of mobility. especially because it's transforming and you can all notice it everywhere. Yeah. And also the topic that we are having is innovating on wheels. I think in a lot of way aptly selected, because except the patch of the postcard size patch between the wheel and the ground, everything else is changing. So I think that will also be lifted off. I think in the next panel by the E-planes guys, we will probably get off the ground. But so far in this panel, let's stay on the ground and talk about what is happening in this whole space. Yeah. So I'm excited to question and get a lot of insights on this. Yeah. With this, let me start probably with the first question. In a way, on the overall automotive R&D space or ERnD space, because the automotive market is growing. I think we will grow north of $1 trillion USD in 2035. The ERnD space is also growing north of 100 billion maybe in the next 5 years. And a major contributor of that is the automotive ERnD. And a lot of us have big centers here and would like to hear from each of you, how big is your center, what are its priorities, how are you changing the R&D of the globe and the local markets. So this is probably my first question to start with. We start with you, Rahul, on this.
Thank you, Jaidev.
Yeah.
Good afternoon, everyone. So I come from Stellantis, as is already announced. So Stellantis is the third largest automobile maker in the world. So we have about 14 iconic brands across Europe and North America, as well as other parts of the globe. So just to talk a little bit from the context of what you've given, and so how is the ERnD space evolving and what is the digital technology hubs that we are starting in India going to help on this? So look at the talent. And so from a talent perspective in India, we have an abundance. So today you take off any major OEM or major automotive player, they would have their GCCs in India. So why? Because of the talent availability. Without the talent at the scale that we can, and at the scale at which we can get the digital skills that are required for the transformation, none of the OEMs will be successful. So you would see this growing almost at multiples in the coming years. So just to give you some stats, so as per NASSCOM survey, there are about 5.5 million engineers in technology space. In that, about 1 million are in ERnD space. And within that 1 million, close to 600,000 are working on technology, software, embedded systems. So these are the areas in which they are working, ERnD space. So it's actually, in the next few years, 33% growth annually is what is anticipated in this space. So that is from a talent perspective. Similarly, if you look at product perspective, right? So the headquarters, so I hate to call this word headquarters, but the headquarters are your parent companies. They expect you, it started like, I'll tell you, you do this XYZ development or XYZ activities. That's gone now. So today we are talking about product-centric approach. How the India teams can really take the product and run with it. So end-to-end product ownership and end-to-end development for the most part is happening through the GCCs or the ERnD centers that we have. So just to give an example from Stellantis perspective, we have our centers in Chennai, Hyderabad, as well as in Bangalore. So we have something called a Stella Brain. So that's the product which actually connects your in-vehicle ECUs to your the edge, to the cloud. So this platform is completely owned and developed by the team in India. So they collaborate with the global teams, but completely owned. So that's the kind of product ownership that people are expecting. Similarly, Stella's Smart Cockpit, which is basically all the experiences that you get in the cockpit. So that is completely developed and owned by the teams in India. So that is how the centers here are evolving. Similarly, innovation. These centers are really created for looking innovation from a different perspective. So I'll give you a couple of examples what we have done. At Stellantis, we have collaborated with IITs or IIITs of the world, where we run hackathons with them. And then they develop the solutions. And then we take those solutions and see the feasibility of implementing them. So things are evolving. So Indian ecosystem is really supporting global in terms of creating this infrastructure, creating this kind of an environment. So last but not the least, digital transformation, I think most of you are aware. Today, we have all the skills. You talk about data, you talk about agile ways of working, so you talk about cloud, you talk about security. We have the skills in abundance in India. How do we really leverage that for the global ecosystem? That's the key for success in the Indian ecosystem point of view.
Thanks, Rahul. Maybe Bala on R&D, yeah, R&D BCI.
Good afternoon all. Thanks NASCOM for this wonderful organization. I think across India there are several locations and it's covering almost each and every industry participation in this kind of event is really amazing. So first before I start, I just want to understand how many of you are core automotive engineers here. Can you please raise your hand? There is a very fraction of the audience. So we don't go into the too much detail about the automotive, but we talk more on how the application is needed from, I think remaining are more on the digital and the business services, right? How many digital side? Okay, thank you. So I am from Renault Nissan Technical Center. So it is headquartered in Chennai, and we are 10,000 plus employees. Companies I can say it's the largest automotive OEM engineering center in India. So we are having a global engineering activities. 8,000 kilometers away, our real development happens in France or Japan, but we work here. The digitalization of the vehicle development really helps to do this kind of development from Chennai. And we have also the ISIT and global business services. So coming to the question of how the ERnD is currently in India. So we have a bigger population working on global development. So we are able to do the full scope of digital development of the vehicle. That means we start from the concept until we kickstart the tooling. That's the phase we call it as a digital phase of the vehicle. So about 30 years ago, there is no digital phase. Everything is physical completely. If you have to design a vehicle, you have to go to a drawing board. We make a draftsman. There will be drawing the vehicle. But now there is no more draftsman. Everybody is working in the computer. And we can say it's almost 30% digitalized, 30 to 40%, but the future is more and more digitalization. The physical phase is getting reduced. So what does that mean for India? So when the digital phase is becoming the bigger portion of a vehicle development, that means, so we have a bigger opportunity in India to do the, using our capability, using our core strength. So we have a bigger opportunity in India. In 15 years, Renault Nissan, when started this technical center from zero, now 10,100 people. It's a phenomenal growth of automotive. It is possible with all the engineers. It's not just core automotive engineers. There is a lot of digital ISIT engineers. There are a lot of digital engineers who have transformed this company in India. It is not just for limited to Renault Nissan, as Rahul said, for Stellantis, and Candy will talk in next about Ford. So there is the future of automotive ERnD is in India. So I think that's the biggest advantage what we have in the digitalization of the vehicle development when it starts. And every one of you are going to play that bigger role to do that, and we are all together to achieve it. Let's give a big round of applause for this moment where we are moving. Thank you.
Candy, can you weigh in your thoughts on this?
Yeah, thank you. First of all, very nice to see the team here. You all had a choice, but you choose to spend time here, so we will make it very interesting and knowledgeable for you as much as we can share. As you all know, Ford is not producing cars here. we have the second largest technology center outside of Tier 1, close to 13,000 people working on various areas of work. And it is possible for us to work here and support the global work, primarily because we can do those work remotely here. Right? Some of them are IT, you all know. Some of them are the payment services, credit services. I think the previous panelist talked about loans. I think there is a Ford Credit which handles quite a lot of customer loans as well as the dealer loans for the global. And from our side, if you really look at it, to Bala's point, there is a huge opportunity for us to do digital engineering. For example, in our case, starting from the product feasibility, it is easy to design the car. Of course, Bala may say it is not so easy. But if you look at it, one of the comments from Elon Musk is that it is the manufacturing hell. That's where I think most of the situation where the rubber hits the road. We need to make sure that what engineers are designing, those product needs to be delivered in a scale, right? And that is where a lot of these activities, for example, we get the product CAD from the product engineers, and then the team designs the bill of process, how that parts needs to be arranged in a way that it can be assembled, and then do the feasibility for assembly, do the line rate, and then start the tooling kickoff, get the tooling design done, and then give the tooling design to the supplier. And once that equipment comes out that is getting installed, get that equipment connected to cloud, and then get the data back from the cloud. So it is a full value chain. If you really look at it, that's what we call it as a digital thread, so that every system is connected. But today, you can imagine the companies with 100 years of experience, we have all bought softwares at different point in time from different vendors with different capabilities, not sharing the API. So now we are trying to do this digital thread so that every product, different softwares can talk to each other, and we can have this seamless work environment for everyone to understand what's going on as a collective skill. So that's our one of the biggest focus area. I would call that as digital engineering transformation. With this transformation, we think we should be able to get 50% reduction in our time, because as Bala said, the product development is not about just getting the product. Like Rahul mentioned, all the talent we need to see how quickly we can launch the product, right? How we can get the product quick to the market. So all of these will be enabled by the digital systems and also the digital talent. That is one of the reasons why everyone is looking at India as a country for developing and having their center here. Thank you.
Thank you. Thank you, panelists. I think very interesting thoughts. I mean, very amazed to see the kind of engineering work done at Stellantis. Bala already declaring future of ERnD is from India. And Ford having the second largest R&D center away from your headquarters. So all this for sure tells us one story, at least as an engineer. I started with automotive. When I started in the year 2000, I have to admit that my German counterparts and Japanese counterparts were much ahead, maybe 10, 20 years ahead of me in terms of engineering. We had to learn from them. But as we enter into this decade, thanks to the digital transformation and so many things happening, I feel we are on equal footing. This is a decade where, as you said, the opportunity is ours to grab, and we are working, and we should work on topics shaping up the global automotive space, as well as addressing the local mobility requirements. But in this, Bala, we will have a lot of talent and capability requirements. And it's not, we have to transform the engineering to go into this level, yeah? So how is that journey, Bala? I would be happy to hear from you on that, yeah.
That's really a key question. That's the most important question. Talent, resources, skills. So automotive industry is focusing on 4 key areas. So we call it as a case: connected, autonomous, shared, and electrified mobility. So as you see, there is a lot of talk about electrification. It's pure electrification or hybridization of the vehicle. And there is vehicles are getting connected. There is a lot of app where we can control the vehicle. We can start the vehicle remotely, and we can start the air conditioner remotely. There is autonomous, where we talk about level 1, level 2, level 3. And Europe is now done level 2 of autonomous vehicle. So when we start something new, it's a niche. It becomes a niche where we don't have resources available. There is no talent pool available. And where do we start? So basically there are 3 options, I can say. Option 1 is we hire fresh talent. Of course, reskilling is more like you're onboarding somebody fresh and you develop the new talent. So that can be the first one. You hire somebody as a fresh talent, and you develop the skills, conduct training, and grow together. So option 2 is we can outsource. For example, ADAS, Conti or Valeo become a master. They are kind of a full development responsibility they are able to handle. So we outsource the activity to such a outsourcing company, or we can take some vendor in the role and BOT, build, operate, and transfer those people. Third thing is about there are certain people who are working in the connected domains, and we move them into the new domain, and easily we can develop. For example, there is a ADAS simulation. So we take people who are working in vehicle dynamic simulation, who are closer to the field, and we can develop the new skills of ADAS into this. So depending on the new domain of activity where we need to develop, we have the strategy. So it can be option 1 or option 2 or option 3. It can go into different things. But there is also a most important option. It is how we can develop our ecosystem within the country that helps for everyone. One is the supplier ecosystem, like Valeo or Conti or several other industries which are setting up centers here, and they develop the competency they support. Second, the universities. So there is a big role and universities can play. For that, the universities has to be ahead of industry. So when we talk about autonomous, the universities have to develop autonomous vehicle, demonstrate the autonomous vehicle, which is happening in some of the universities in US or in Europe, and we don't deny that there are few universities in India also ahead, but we need to develop such ecosystem everywhere. So we work, industry work with some of the universities to develop such ecosystem. That will really pave the way for accelerating the talent pool availability in the country.
Thanks, Bala. I think very interesting thoughts on our ecosystem, and especially the last point on the universities, because what I noticed is when Korea developed, China developed, the universities all alongside also developed, and the number of patents the universities are producing are also equally increasing, day by day. I think that ecosystem also has a very great role to play. So yeah, that's good. Maybe then with the background of ERnD, let's move on to a clear technology topic, because without this, vehicles of today are getting this distinction that it is going to be software-defined vehicles. As I said, innovating on wheels, I would say it's becoming like a mobile on wheels, data center on wheels, whatnot. There is a different ways in which the software-defined vehicle is evolving, and each OEM, each supplier, each partner in the ecosystem of this, even the system-on-chip suppliers, they all have a way to approach this software-defined vehicle. So I would be interested to know how different OEMs are approaching this. Maybe let's start with Candy on this.
Yeah, thank you. So if you really look at it, historically, the organization, especially companies like us, including I think Stellantis and others, we had a product development team, and which is heavily focused on, say for example, the hardware systems, seat, instrument panel. That's how the organization structure will look like. Underneath, there will be an engineer who will be focusing on getting the control module for that particular system. That is how the organization structure is. it was, right? Now, if you look at it, we have got a clear separation. There is a vehicle hardware engineering, there is a vehicle software engineering. So software is becoming a big piece of the entire, the value chain, right, which was lower at the level. Now it is hardware and software. We have a vice president for hardware engineering, and also we have a vice president for software, right? And these softwares, initially, as I mentioned, it was all underneath individual subsystem. There were a lot of challenges in terms of communicating that one system to another system. And the protocols were all very much defined by who is designing that particular system. Now, all of these things are brought under software team, and they are really rethinking the way how the architecture is looking like today, right? Today, the architecture is individually every systems are developed. Now we are going to have a common architecture, and the signals from each of those systems are integrated into that, the big processor, and then from there, everything is getting connected. So the software piece of it, if you look at it, we are heavily investing it to do a lot of development at Ford in-house, and there is a role which multiple players are doing, including like, Bala's point, there are areas where it is going to take us a lot of time to build the capability. And if there are some software, we find some startup which is really doing extremely well, and we feel that is going to add value. For example, there is a startup called AMP, which has matured their technology in terms of how the battery management system should look like, because the energy consumption, how we should really manage that. They have spent a lot of time, and there is a good system. So Ford has acquired that company, and that company has got people working in Bangalore also. Of course, there are people in North America. So that kind of, acquiring talent, buying the talent is also happening. So the software is becoming a very, very critical differentiator also. For example, in the previous session, people talked about hyper-personalization. Now, as soon as you walk into the car, it welcomes you with a name, right? Very happy to meet Rahul again, right? That's how the personalization is happening. So it becomes a very critical feature, and people are able to see their car status on the app. And like Bala said, we can start the air conditioning before you leave your office or your home, so that the vehicle is absolutely ready. So the software is playing a huge role, and the people who understand the software, and there are a lot of capabilities available in India. Every company, including Ford, we want to make sure that the skills and capabilities is leveraged from the ecosystem what we have got, which again, the universities and talent is ultimately the critical piece here, right? So that's where it is going to be, we'll be able to convert the requirements into a good software, and the good software getting into the customer hands with the superior user experience.
Great, thanks, Kenny. Rahul, you wanted to add?
Yeah, very nice views. I just want to add a couple of additional points there. So if you look at SDV, or the software defined vehicle, as Candy also mentioned, we are basically separating out your hardware and software. This is what you're doing. Today, the differentiator that you're looking for in a car, 99% of the time are software features. Because the basic hardware is going pretty much the same. So you're going to have the powertrain, or you're going to have the steering and seats and everything. So in that context, as Bala also mentioned earlier, how do you reduce this whole life cycle so that you improve your time to market, right? So if you differentiate these two, and then these two can run independently or parallelly, you are moving away from your traditional V-cycle model or waterfall model into more of an agile model. So that's where you gain that time, and then you also be able to really produce a feature-rich product in a much faster. So if you look at, there's something called as vehicle stack. I don't know how many of you know. So vehicle stack is nothing but it's like very similar to your software architecture. So you have your ECUs, you have your sensors, Then you have the operating system which is inside the car. So this is one layer. Then gets into your middle layer and API layer, which is actually transforming your data to the cloud. Then you have your application layer, which is what we're talking about. How do we really manage that from your phone or any other device, right? I mean, so if you look at that particular stack, it pretty much looks like your entire software program. I mean, so that's how it is looking like. So we are moving more and more towards software in this automobile area, I mean, so as we move forward.
Thanks, Rahul. I think this software-defined vehicle certainly is the in thing. And maybe when Bala started, many of you said you're not from the automotive domain. I think going forward, it doesn't matter. It doesn't matter. Because automobile is becoming more and more software-defined. Maybe just for the audience to a little bit grasp what we are talking about, I think Rahul brought up some use cases. So one recent use case where I was amazed is, you've seen the Hyundai Ioniq, which is a completely EV vehicle, yeah, in the market. And you walk in and you say, I don't want the EV features, I want it to sound like an IC engine. Then there is a software skin it puts on and makes you feel like it's an IC engine. And that is what the software is actually able to do. Yeah? So now see the kind of possibilities with software. It's really great, and I'm very happy our Indian engineering is really working on these things and possibilities there. Yeah? And this is also overlapping multiple industries. So that way there is a lot of the software trying to democratize and bring things together. So that's great. Yeah, thanks. But maybe the next question, we've talked about software, but from picking up, I think it's not complete if we don't talk about AI. So what AI is going to do, and AI inevitable today, it's going to come and transform and create a lot of opportunities for innovation. But how is automotive taking it? What are the use cases it is driving? Rahul, can you weigh on that? Yeah. Yeah.
So thank you for that, Aman. So since morning you would have heard this mostly abused words of AI and ML in today's context, right? So today, any industry for that matter, I mean, automobile is no different. So there are multiple use cases of AI, for example, for us. So I mean, just before this, there was a panel discussion, so I'll make it a little lighter by giving a joke. So if you look at the customer experience or hyper experience, and so as Candy and Bala were also saying, the moment you get into the car, you want that personalized greeting. So you want your car to really remember what are all the things that you've been traditionally doing and giving you that suggestions. So optimizing your route. Or there is a traffic jam on a particular route that you take normally, so take an alternate route. So this is the kind of experience that you are expecting. So, and there are also perils for it. Hyper customization or hyper personalized experience. So I'll give you a joke. So again, don't take it serious. This is we play in the industry. So there's this guy who goes to office every day in a particular route. So on the way he stops at a Starbucks, picks up a coffee. Then he stops at his girlfriend's house, and then he goes to office. So one day he stopped at a Dunkin' Donuts, and then the car says, usually you take a Starbucks coffee, why are you taking a Dunkin' Donuts? So you don't want your car to tell you what coffee that you need to take, right? Okay. So this is one experience. Then the other day he takes his wife along. And wife divorced because the car said, you are usually stopping at your girlfriend's place, why are you not stopping today? So that is the extreme of personalized experience, right? So this is one use case of AI. So similarly, if you take the biggest problem most of the OEMs face is the recalls because of the issues that you have with your vehicles. You are doing most of the time the reactive maintenance of it. So you get the problem, then you analyze, the engineers go back, and then finally find the root cause, then you fix it. So this is a very expensive affair. With AI, you have all the sensors giving you all the data at real time. So you can mostly predict when is that failure is going to happen. So you can probably arrest that much in advance. So this is probably in that use case. Similarly, AI, if you look at it, with Chennai is coming in, most of you, from last August, the topic is Chennai for the most part. There are use cases where you can draw a rough sketch of a car, or you can take a voice-based command and then give it to Chennai and then say, this is how I want my car to look like, and this is the rough sketch of my car. and Chennai is able to give you that kind of options or designs. So you're basically reducing, as Bala was saying, so the engineering life cycle or the prototyping life cycle. So that's becoming more and more digital. So that's another use case. So similarly, if you talk about supply chain, where is my vehicle today? So to that extent, so I think Ford has actually implemented this. I don't know about GM also. They can precisely tell you what is your vehicle with the VIN number, where it is in the factory, whether it is in stamping or whether it is in paint shop. To that extent, they are able to really give you the pictures, saying this is where your vehicle is, and now it has come to dealership, go and pick it up. So that's the level of data that we are getting and also processing and able to really give it back to the consumer. So this is really transforming the way we are operating today.
Understood. And yes, Rahul, I think innumerable possibilities with AI, and that is going to be exciting all of us, how this is going to operate, and some fun as well in the process, yeah, for sure. Without harm. Yes, the ethical side and the other sides of AI also in discussion. But these are the dichotomies engineers are always liking. Is it safety versus comfort, AI versus our intelligence? So I think this is going to be the fun of engineering that's going to happen in the future. But speaking about the possibilities in the mobility space from a technological standpoint, from what the engineering can do, I think we will not close the topic if we didn't talk about responsible engineering, because we need to preserve our planet. The mobility space is contributing almost 18% to the CO2 emissions. We need to decarbonize. And this is also a very big opportunity, at least for the Indian engineering, because these are topics across the world on the table at simultaneous time, and everybody has to operate from that. So maybe Bala, we can talk about what are we doing about green vehicle, both from the global perspective and the local perspective. Okay,
so this question is not everybody's mind. It is on top of our head. So how you gift the earth to the next generation, that depends on how we are going to preserve today the CO2 emissions. So COP26 in Paris a few years ago, there was an agreement which was signed by 120 countries. So in that agreement, Europe agreed that 2035, they will move 100% electrified vehicles. India is aiming at 2070, 100% electrified vehicles in India. There are several other countries who are making a target between this period. That means 2035 to 2070, we can call it as a EV evolution, EV revolution maybe. So this is the green energy evolution which will happen in across the world. So India, like global manufacturers who are working for European vehicle development, we all will be developing. Already there are electrified vehicles. Today in Europe, about 20-25% of vehicles are electrified, even though India is only 1% of passenger cars and 5% of two-wheelers are electrified. But the path is very long, but there is a lot of learnings coming from Europe preparation. Everybody will prepare for vehicles in Europe. So when it becomes 100% electrified vehicles in 2035, with that learnings, I think we will take it forward, and it will be easy adoption for India, at least I would say, because we already learned what are the challenges and how we have to develop. Basically, there is a big challenge on the ecosystem. So that part also to be addressed. As a large country like India, the biggest population in the world. So we may have several challenges that has to be addressed, but we have a time to meet those challenges. But first challenge is how we are developing the vehicles to electrify until 2035 to reach 100% electrified vehicles. So that is becoming a green revolution.
Understood. Again, interesting. The point of 2035 becomes important because if going by what is 2050, we stop, we completely stop tailpipe emission, and at least in the developed worlds. 2035 will be the last fossil fuel vehicle manufactured and sold. So I think this is
No, just
great
what
potential.
Radha,
Yeah.
so very similar to the global players. So from Stellantis point of view, by 2030, we will not produce ICE engines in Europe. So it will be completely electrified vehicles. By 2038, we will not produce ICE engines in North America. And so this is the commitment that Stellantis has taken. We call it as their forward strategy for 2030. So you would see more and more OEMs moving in that direction in terms of carbon neutrality.
Yes. Thanks. Thanks for. I think this is a bit of responsible engineering, and here as well, as I said, our automotive R&D from India has a scope to play. As I said, we can take the lead, and in a lot of ways, it's also our civilizational value in protecting. And I think this is what is also generating a natural passion for the people, and I can notice that we are also taking the lead. Okay, I have a couple more questions, but before that, let me also engage the audience. And audience, over to you. Any questions that you want to ask? Yeah, please go ahead. Oh, quite a bit. Thanks. Right. Mics, please.
Check.
Yeah.
So now that SDV is going to be the future, what are the kind of investments made in ensuring the software updates are in place? Because an average lifetime of a consumer vehicle is about 15 years in the market. And now that your time to new model is also shortened to a matter of months and not years as before. So at any point of time, I would imagine about 10 to 15 models to be maintained for the market. It's already out there.
Candy, you want to? Yeah, please go ahead.
Yeah, so I think there will be more markets available, more vehicles available in each market for the consumers to choose, right? And there will be more vehicles, there will be more brands. I think if you really look at it today, even from India, for that matter, if you look at what are the OEMs which today we have only Tata. After some time, Ola will come and few other companies may come, which will be, MNC or a local manufacturing company which is born out of India. Similarly, if you look at China today, there are more than 30-40 players already in EV. So we are going to see a lot of investments coming there, and I feel that, it will be further. It won't be like one company dominating a lot of shares. I think that also might change as we move forward. Any views?
So basically, today there is a software update. It is happening in vehicles. Are you aware?
Yep, over-the-air updates.
No, the over-the-air update is only for a few vehicles. Like MG is introduced, and everybody is going to follow. But there is update when the vehicle goes to service. There is a new patch or anything in the software. It happens now. So FOTA is going to be the future. It is already started with the MG, and suddenly government realized there is no control over the software updates over the air. So now they were thinking about introducing a cyber security system on the vehicle software updates. So that's going to come in another 2-3 years. So once that is established, I think we may have to do this update. Why the update becoming important is autonomous feature. So when we have autonomous feature, we are inbuilding some scenarios, like, so we cover a lot of scenarios, but there is a new scenario which is coming. So we need to integrate into the vehicle. There is before such adverse effect happens in the vehicle. So the vehicle becomes really, see, for example, in mobile phones, when there is a cyber risk, so there is a patch which is keep coming. There is a iOS updates. Similarly, when the vehicles are with autonomous features, there is going to be a lot of updates have to happen. So that becomes a standard affair. Once the cyber security is established in the country, I think the update will happen very soon in India.
Yep. So just to add one more point there, so if you look at the updates, today, yes, so as Bala is saying, you have to go to a dealership to really get your updates, but the future is going to be OTA, so over there updates, so that's how it is. Do we have the infrastructure everywhere where you get that kind of a speed to really get that software updated real time? That's the challenge. Not only here, so everybody is going through that. 5G is probably a solution that everybody is anticipating that it would solve the problem. So the second element to it is the vehicle-to-vehicle communication or the vehicle-to-infrastructure communication, which is what is called as V2X. All that need to happen with some kind of standardization. Today there is no standardization. Vehicle-to-vehicle communication protocols, are they standardized? I don't know. So there are multiple different ways that each OEM is doing today. So how are we going to get to this kind of a maturity so that what you are talking about is risk-free? At the same time, the fundamental aspect from an OEM point of view will be safety. So you are not compromising on the safety of the passengers. So in that context, these are all the things that need to evolve. Hopefully they will evolve sooner so that you will have a better experience. So that's what I would say.
Thank you. Thank you. Thanks, audience. We are running out of time, but we are all available later if you would like to catch up with us on. You're pushing. Okay. One last question. Go ahead. Sorry. Mic with you? Yeah.
Hi.
Make it fast, quickly we can conclude. Yes.
Sorry for the disturbance, sir. Myself, Dr. Mithun Kumar from JPR Engineering College and JPR University. Actually, I am from an IT background only, okay? So I don't know much aware about the mechanical things because right now we are implementing everything through the physical things only. What do you think about the driverless cars in supportable in India, sir? Actually, recently I heard some YouTube videos and all. Some of the driverless cars are implemented in US. So how the possibility to support in Indian roads? What is the possibility we are getting here in India?
Okay.
So that's
Driverless.
okay. So that's not called autonomous level 4 or level 5. So we are now level 1 or level 2 we are discussing. So Europe has implemented level 2 of autonomous. That means we don't keep our completely away from the steering wheel. We keep our eyes on and hands off. So level 5 of autonomous is a long way to go. We are not in that. Today there is a level 5 autonomous possible in a defined route. Maybe if you take, for example, inside IIT Madras.
Okay, fine.
So there is a defined path where the vehicle can go different places, it can stop, it can go. So, and there is not so many scenarios, uncertain scenarios exist. So that's where it's possible in some of the areas it is in Singapore or in US or in Dubai, such trials are ongoing. Okay. But for a global mass introduction, it is a very long way to go. Understood. We are still struggling for level 1 today. Level 1 as autonomous driving.
Understood. So I think I will bring this to a close. Thank you very much. As I said, you can always approach us with your questions during lunch and so on. We are available here. So one last thought before I close. I think the interest is already seen because the future through tech.
One more question.
No.
Is it open?
No. No? We'll take it offline, guy. Yeah, we'll stop it. I would like to say the future through tech lens from the mobility space is always interesting. Last 20 years, mobility space has always been at the engineering forefront. In this decade as well, if you look at data, a car is going to collect massive amounts of data. We are going to push the cloud and the data to its edge. You look at AI, if the vehicle can travel with AI, it can any other AI technology will also benefit. We are going to push AI to the forefront. So any new technology is happening, the mobility tech will also push it to the forefront, push it to the limits. And that's always been the beauty of mobility. It pushed mechanics, it pushed electronics, now it's going to push software as well. So with this, I will close. Thank you, audience. Thank you, panelists, for the insightful session. Yeah? Thank you.
Thank you so much, sir, for that insightful discussion being facilitated. I would request Mr. Lux Krishnamurthy, Vice President Engineering, GM and MD, Caleris, to felicitate the panel moderator and the panelists with a memento.